Video is going to talk about how we can use sum and difference formulas to basically accomplish two tasks. Number one, we can use them to verify identities. So we're familiar with the cofunction identities. The sine of pi over 2 minus x is really equal to the cosine of x. But why? Well, if you notice on the left, we've got the sine of two angles subtracted. So if we actually split that up using our sine difference formula, remember that the sine is the sine of pi over 2 times the cosine, right, of the second angle, so we'll call it x. The sine stays the same, so again, minus the sine of the second angle times the cosine of the first. And again, we're still going to say, okay, we're trying to prove we're equal to the cosine of x. Well, in that case, let's plug in some values that we know. I know that the sine at pi over 2 is really equal to 1. And I know the cosine at pi over 2 is really equal to 0. Well, very simply then, 1 times the cosine is the cosine of x, minus 0 times the sine is 0, and really we end up with the cosine of x, which is what we wanted to be equal to in the beginning. Therefore, our good friend Q, E, D. All there is to it. Now, that's not the only place that we can use sum and difference formulas. Really, a really helpful spot is when we're solving equations. So you'll notice this is a very messy looking equation up top here, and it's only going to get messier because I notice that I've got the sine of a sum and the sine of cosine of a sum and the cosine of a difference. Now, before I get too far into it, I do want to notice that I'm working with radians, so make sure you're set to radian mode if you plan to use your calculator at all. Also, we're going from 0 to 2 pi, so I'm not looking for general solutions. I'm only looking for the answers in that first circle on a unit circle, right? That first time around, only from 0 to 2 pi. Well, I'm going to go ahead and use my sum and difference formulas. The sum of a cosine is cosine times cosine minus the sines of the angles. The cosine of a difference, again, would be cosines of the angles plus sines of the angles multiplied. And notice the minus in between here. So we've got our difference in between sticking around. Still equal to 1. Now, a great idea would either be, well, we can find our values here, or we could take that negative, let's go ahead and distribute it, which is actually what I ended up doing. I'm going to go ahead and distribute that minus sign. Cosine of x, cosine of pi over 6. Then when I distribute the minus sign, again, cosine x, cosine of pi over 6, I went in and wrote that as my second term here. Just noticing I've got a lot of cosines, I may as well write those all first. Then I've got a minus sine, and notice it'll become another minus sine. So basically, the first two cancel away, right? Cosine times cosine minus cosine times cosine. The second two just double up, so I get negative 2 sine of x, sine of pi over 6. Now is a great time to go ahead and find the sine at pi over 6, which is the sine of 30 degrees. Which really, that just is equal to 1/2. Negative 2 times a half is really negative 1. And if I divide by negative 1, I want to know when would the sine of x equal negative 1. Well, on my unit circle, sine is always the y-coordinate. It's going to be equal to negative 1 down here, or basically x equals 3 pi over 2. And there's my solution. All there is to it. It gets fairly messy at first. Just make sure you take a good look through your terms. Again, those plus and minus signs can be very helpful for us. Sometimes we get those common terms and they'll simply disappear, or we can add like terms before we go and find those simple values, right? Sine of pi over 6 is definitely an easy enough value to find. Let's look at another example real quick. Again, we've got a tangent difference and a cosine sum. Now, I don't love having those mixed together, but let's go ahead and spread out those sum and difference formulas. Now, this time, since we don't have a lot in common, we got tangents, cosines, sines, I would go ahead and evaluate what you can when you can. Right? So the next thing I'm going to do is go ahead and evaluate these. The sine at 3 pi over 2 is negative 1. The cosine at 3 pi over 2 is 0. So 0 times the cosine, well, that just all disappears, right? That's just 0. So all I really end up with is a negative times a negative 1. So that's a positive sine of x times 2. And in the first part here, the tangent of pi is 0. So this entire problem on the bottom turns to 0. And basically we get a negative tangent of x over 1 plus 0, or basically just negative tangent of x. Well, now, because I've got tangents and sines, a great idea is go ahead and let's get some functions that maybe work together just a little bit better. So the negative sine over cosine, I'm going to go and take out that tangent. Now that I've got a couple of sines, it'd be nice to have a common denominator. But then again, we could go a different route as well. Notice I've got a sine in both parts. Hey, that's another thought. Why don't we just take out the sine of x? That leaves me with negative 1 over the cosine, which will be a negative secant. Again, we took out that sine, so that's just a 2. And now, if these two things are multiplied equal to 0, well, we can separate them. And the sine of x equals 0, again, if we think about our unit circle, sine of x equals 0 and at pi. So again, a couple of our answers, x equals 0 or pi. Let's see if we can't find a couple more. If we subtract our 2 and divide by negative 1, that would tell us that the secant of x, right? Again, subtracting 2 and dividing by negative 1 is going to be equal to, which is the same thing as saying that the cosine of x equals 1/2, which I know happens at 60 degrees, and it happens at 300 degrees, or in radians, right? So 0 and pi, but also at pi over 3, or 7 pi. Oops, sorry, 5 pi over 3. 7 pi over 3 would be a full 2 pi away, right? That'd be a bad idea. 5 pi over 3. And again, I would want to make sure that those numbers all do exist. Again, if I plug 0 back into my equation, I would want to make sure that I'm not coming out with something impossible or undefined. Really, cosine is always defined, but again, tangent doesn't exist at pi over 2 or things like that. So if I was plugging in a value, I'd want to make sure that that's still not an undefined value. I believe all 4 of those should work for us. But again, it wouldn't be a bad idea in the end to go ahead back and maybe graph this from 0 to 2 pi and see if those 4 answers do pop up, right? Or you could just plug in those 4 values, type carefully, and make sure they all work. Let's get to this last example real quick. Again, we've got the sum of a sine, we've got the sum of a cosine. So if we spread those out, we're in good shape there. Then I'm going to go ahead and take that negative and distribute it. Right? So if you imagine, I'm going to go ahead and say plus. This is going to be a minus and a plus. Well, in that case, we have a whole lot of stuff going on there. But again, lots of mixed sines and cosines, nothing that's really like terms. So let's go ahead and find some values. The cosine at pi over 2, again, is going to be 0. So this whole term turns to 0. Basically, we can ignore it. The sine at pi over 2 again, right, is going to be a 1, which means this is really just the cosine of x. Over here, cosine again at 3 pi over 2, again, is also going to be 0, which means this whole first term turns to 0. And the positive sine of x, sine at 3 pi over 2, is going to be negative 1, okay, which makes for a minus the sine of x, still equal to 0. Now you can either add sine of x over to the other side, and then think about when would the cosine and the sine have equal values, or you could try to play around with that a whole lot, maybe divide by a cosine on both sides, or a sine on both sides, and try to play around with some tangents. I'm actually going to take the first route and say, well, hey, if cosine equals sine, the only two places that that's going to happen, or the only place that can happen, is on the line, right? Y equals x. So for me, I'm thinking that means that can only happen at pi over 4, or down in quadrant 3 at 5 pi over 4. I would take those answers again, make sure you double check them, but I'm pretty sure those are the only two places we're going to get answers. I hope that helps you again solving equations. Make sure you talk to your teacher if you have any questions. Otherwise, happy trig, Good luck, have fun, and have a great day.